Hello guys, welcome back with me, Chow Chow 2025. Today, we're going to learn how to create LoRa with Kohya SS. This time we're going to do it offline using our own GPU to easily install Kohya SS without any problem. I am going to use Pinocchio. How to use and install Pinocchio will be put on the link on video description. Now open Pinocchio. Click Discover. Search for Kohya SS. You will find Kohya SS one-click installer by Cocktail Peanut. He or she is a verified script publisher, so there is a high chance that the script is safe. Download the script, save as anything you want. As for me, I keep the original name, that is kohya.pinocchio.git. Click Download and download will be started. After it finished, click Kohya SS. After that, click Install. A long installation process will be started. Depending on how many requirements that you already have, it could take a while. There might be steps that are now shown in this video, like installing Visual Studio and other. Refer to video of how to install and use AI text to music engine, AudioCraft Plus for more information. Link is on description. The installation process will download and install so many things, so be prepared to get bored. When the process is finished, there will be a message saying install success. Go back to the dashboard to launch the APPL. Click Launch to start the Kohya SS application. Now that we're able to run Kohya SS, time to training a LoRa. The first step is to prepare the image. In this case, I prepare this 11 nm image from Suikoden game. Save the image in one folder without any other file. The next step is to caption it. You could caption the image manually by creating a text file with the same name with the image file. Then write your caption of the image. Or you could automatically do that using blip captioning. To capture the character in uniform, make sure the caption has both. In this example, there will be a woman for the character, in red or in red dress for the uniform. How to do that is from Kohya SS main screen. Click Utilities tab. From there, click Blip Captioning. Select the folder that you want to caption in image folder to caption. You could add prefix and postfix to your caption. Prefix mean you could write your own tag in the first word or prefix on the last word. Or you could just leave it blank if you don't want your LoRa to have some kind of trigger word. After that, click Caption Images. Captioning images will start. If this is your first time, it will also download the model automatically. After that done, now in your image folder you will see a lot of new TXT files that are the same name with the image. The next step is to prepare the training dataset. Create a new folder for the main LoRa dataset. I call the folder Nanami LoRa. In that folder, create 3 new folders. I name it Images, Model, and Log. You could actually name it any way you want, but this is the convention, so you are not confused. Now, access the Images folder, or the folder that you will put your image. Now, created a new folder. For the step, there are 2 conventions. The first one is to create results that are really resemblance your images. It will make a strong impact that the images hardly change. The second one is the soft one. The first one is using 1500 step total per epoch. The second one is to use 10 step per image. Here are the example of the first way. You need to divide 1500 by the number of images that you have. If that image is less than 100, you then use 100. In this case, I have 11 images, so 1500 divided by 11 is 13,636. I round it into 137. So then I created a folder under image name 137_nanami. Now move all the images and caption that you created before into the folder. Now we're done with that. Back to Kohya SS. Click LoRa tab and click Training tab. This tab will decide which checkpoint that will be used to create the LoRa. For source model, you could use the default list or the custom. If you select custom, you then will be able to select the model file. In this case, I use absolute reality checkpoint. If you use SD 1.5, make sure to uncheck V2, V parameterization, and SDXL. Next, click the folder tab. In the image folder, put the link into your image folder. Output folder mean to put the model folder. Logging folder, then put the address of log folder. You can ignore regularization folder. Also, don't forget to name your model in model output name. This will be the LoRa name that you will use to call the model. Next, click the parameters. You could use preset from Edge. Adjust the batch size and other stuff so it suits your GPU. I used 10 epoch in this example. Also make sure you click image bucket if you use different image size. Also, I increase my max size to 768 and 768. Batch size of 1 in my GPU will take about 7.9 to 8.9 VRAM. Batch size of 3 in my GPU will take about 14 to 14.8 VRAM. Batch size of 2 in my GPU will take about 10 to 11.0 VRAM. After everything is ready, click Start Training. Don't worry about the step that I'll show up. It is a step for all epoch, not just one epoch. Also, you could use Save Training State so you can resume your training from any epoch. But remember that this state will take a lot of space. In my case, one state take about 23 gigabytes. Okay, we skip to the end of the result. So as we can see here, for 10 epoch, it takes about 2 hours 55 minutes. You can see the result in model folder. Here you can also see the state. You can use this if you want to restore training. Every state of the step is saved here. Since we use 10 epoch, that means there is 10 model created. The number on the right is the number of each generation. The last generation will have no number. Now copy the old safe tensor file. Paste it in your LoRa folder. The default location is webwe/models/LoRa. Okay, when it's done. Now open your Forge, Automatic 11, or Comfy. Create an image using the new LoRa. I use Forge in this example, and I use XYZ plot to give you an example of all the epoch result. You can refer to XYZ plot script video for information about XYZ plot and how to use. Link on description. Here I see that epoch 4 seems look great. Another example, epoch 4 to 6 seems look great. Now we will compare Euler A and D++ QRIS result. It seems the Euler kinda ruin epoch 5 and larger. Next, we're going to try other checkpoint for this. This time we're going to use Realization. I adjust the negative prompt for Realization V60. Here are the result. The result is quite good. Also, I use realistic prompt and negative prompt for anime and cartoon, but it seems it is not working. I think I used too much step. If you want a result that somehow look like the model, but not carbon copy of it. Also, if you want to create a model that you could turn into anime or realistic, simply use 10 step per epoch. Here are the example. I also turn off the save state and change the model into anime merge. It take only 13 minutes for this LoRA to be trained for 10 epoch. In this example, I think epoch 8 to 10 is great. You could really change it from anime into rendered or realistic. Although many videos suggest to use the 1500 steps, my preference is the 10 step per images with 10 epoch. It looks great, and I enjoy having a different result, especially if I can convert anime into realistic model. Also could use a QRIS fix for better result. Anyway guys, that's it for today's video. Thank you for watching. Don't forget to like, share and comment. See you again on the next episode. And have a nice day. Please subscribe.